Hi guys, today we're going to go over atomic structure and I've included a link to this interactive in Google Classroom, but today I thought I would go through this with you for those who might need a little extra help. So we're looking at the atomic structure tutorial. Chemistry is all about how atoms behave and interact with each other. In order to understand why different kinds of atoms behave the way they do, we will have to know something about how these atoms are put together. In this tutorial, we will take a look at the parts of the atom and learn about the properties of these atomic pieces. All right, so we're going to click the top of this pencil here. And during this tour of the atom, pay close attention to the properties of the particles found inside. So magnifying to the atomic level lets us see that the carbon atoms are vibrating in place. We can see that right here. This is how we would expect the atoms in a solid to move. Believe it or not, that's what we would expect. All right, we're zooming in further. Each individual atom is spherical, that means kind of round, and seems to have edges that are fuzzy. There doesn't seem to be a distinct beginning and ending points to an atom. Let's take an even closer look at what's inside. Ooh, here we go. Now some of this should start to look familiar. All right, it's slowing down for us. Oh, there it goes. All right, once we stop all motion inside the atom, we see that it is made up of three types of particles. Let's look at each of these individually. The first particle we will look at is the proton. Protons are found in the center of the atom in a region called the nucleus. So it's showing us right here that the proton is blue, and this is what our nucleus looks like. It's those red and blue particles together at the center of the atom. It is the number of protons that determine what element an atom will be. So for example, this atom, this one right here, has 6 protons, just like every other carbon atom. So in order to be considered a carbon atom, there has to be 1, 2, 3, 4, 5, 6 protons in the nucleus. If there are 7, it's no longer carbon. If there are 5, it's no longer carbon. The number of protons is called the atomic number. We're going to do more with that in the coming days, but for now, I just want you to be aware of it. The atomic number, it can be found for any element by looking at the periodic table. So right here, the atomic number is the whole number found with the symbol of the element. So for example, C stands for carbon, and the atomic number is here in the left-hand corner on this periodic table. Sometimes it's right here. And that tells us that there are 6 protons in the nucleus. Protons have a mass of about 1 AMU, or atomic mass unit. The actual mass is not really important, but you should remember that protons are one of the heavier pieces of the atom. All protons have a +1 charge. Protons positive, right? They wouldn't be able to stick together in the nucleus if it weren't for the next particle we will look at. Neutrons. All right, neutrons are the other type of particle that can be found in the center of the atom. So here's the neutron. It's represented by this red dot. Here's our nucleus, and we can see that protons and neutrons make up the nucleus of an atom. Neutrons do not have any charge. Through forces other than charge attractions, they are able to hold the protons together in the nucleus. So what does that mean? That means that it's not attracted by positive and negative, but it's held together by a very strong force. Neutrons have about the same mass as protons, making them a major contributor to the mass of the atom. What we're saying here is that neutrons are about as heavy as protons are, and they make up most of the sort of weight or mass of the atom. The last type of particle is the electron. Electrons are the smallest of the three particles and add virtually nothing to the mass of the atom. In other words, they're so light that they don't add any weight or any mass to the atom. So the electron is represented by these little dark spots here. It should be noted that the atom pictured on the left is not drawn to scale. Given the size of the nucleus, as it is drawn, the electrons would most likely be over a quarter mile away. Is that crazy? So the scale of this is way, way off, but what it does is it shows us sort of a mini roadmap of what we would expect the atom to look like. Electrons give the atom that fuzzy edge that we mentioned earlier. That's because they're in constant motion in the space around the nucleus. Because they're always moving, there is no distinct outer surface to the atom. So there's not a nice wall around an atom. That's not how it works. We have a nucleus, and then we have these electrons just flying around the outside. Electrons have a -1 charge. This is important. So they have a -1 charge and can at times move from one atom to another or be shared between separate atoms. We'll talk more about that later, but it is important to know. Now, we're getting, whoops, oh dear, I'm so sorry. All right, we're getting to some good and important stuff here. So remember that a word neutral would mean, right here, the word neutral would mean that there would be no positive or negative charge. The number of positives equals the number of negatives, okay? Or in other words, if an atom is neutral, it will have the same number of electrons as protons. So here's a neutral carbon atom. We said earlier that carbon is going to have 6 protons, 1, 2, 3, 4, 5, 6. And in order for that carbon atom to be neutral, it's going to have 6 electrons, 1, 2, 3, 4, 5, 6. Okay, that means that that carbon atom has no charge. The pluses equal the minuses. You will spend a lot of time learning about electrons because they are responsible for many of the properties of individual atoms and are involved in all chemical reactions. So let's see what we've learned. What's true about a proton? What's the charge of a proton? Well, remember, you guys should complete this on your own, but I'm going to help you. Proton, pro is positive, right? So we're going to put the +1, whoops, we're going to try to, +1. And the mass, remember that we said that protons were considered heavy. Where are protons located? In the nucleus. And what role do they play in the atom? Well, let's see. That's not true. No, that's not true. Aha, it determines the identity of the atom. Remember, I told you that in order for carbon to be carbon, it has to have 6 protons in the nucleus. So the number of protons determines what the atom is. Let's move on. Let's see what we learned about neutrons, excuse me. So neutrons, let's see, what kind of charge do they have? 0, no charge. They are neutral. Mass, they are also very heavy. Location, still in the nucleus. And the role in the atom, let's see, no, 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 aha, holds together the nucleus. Remember that the neutrons help pull the protons together and give us that strong nuclear force. And last but not least, let's see what we know about an electron. All right, the charge of an electron, negative, -1. Mass, almost none. So remember, they're really, really light and contribute almost no weight or mass to the atom. Location, let's see. Aha, outside the nucleus. And its role in the atom, well, let's look. Aha, responsible for reactivity. Now, that's some fancy wording there, but basically what that means is it allows it to interact or react with other elements. And again, we'll spend more time talking about that. As you continue to study chemistry, you'll learn more about each of the 3 subatomic particles. What you've learned here should give you the background information you need to understand how the number and arrangement of the particles play a role in determining how each atom will behave. We finished. All right, here's what I would like you to do. Go through the tutorial on your own and practice some of the games that I just did, the matching up, and see how you do. And as always, if you have any questions, please send me an email. Bye, guys.